In this video, I'm going to explain domain-driven design in a very simple fashion without any complicated jargon, so that every type of developer, starting from junior up to very senior, can understand this concept. There's a lot of material on the internet about domain-driven design, but it's usually very advanced. So if you're a seasoned developer, a very senior developer, you probably already use domain-driven design or maybe even architected an app using it. If not, it's going to be very fun. So buckle up and let's get started. Okay guys, so the example that we're going to be building upon is a drone delivery app. Okay, we're going to go over all of that. But first, imagine that we're trying to build an app that is basically delivering stuff with a drone. Okay, now before we try to design this thing, what we need to do is that we need DDD for some reason. And the reason is it's a strategy that aims to at improving the quality of our software by aligning it closely with the business needs. In other words, we're going to try to bring these developers that we are closer to the domain experts, also known as the business people. All right. And now if you put all of them here and together with domain experts, now the collaboration between these two types of people is going to be much better and it's going to yield better results. Better results meaning better quality software that's going to be easily maintained over the years. Okay, so when we look at the DDD, domain-driven design, it basically consists of two parts, strategic design and tactical design. In other words, strategic design is an overview of the domain or the app on a higher level, and tactical is on a lower level. Okay, so you always start with the tactical design to better understand what the business needs are before jumping into the tactical design, which is closer to the code actually. To architecting your app. Now, the strategic design itself is basically consisting of some things that are within the problem space. Okay, in a strategic design, we're only talking about the problems, not solutions. So first, we need to identify what value is our app is bringing. Okay, what is our solution in general, and then we need to actually do some knowledge discovery. Meaning, we need to identify who our domain experts are. So basically, the business people that are sitting across the room on your floor of your company, and we need to do an event storming. Now, this event storming is a very crucial part of DDD. And it sounds like brainstorming, right? Where people basically throw their ideas on the board with post-its and then some good ideas are identified and bads are identified. Well, it's actually pretty much the same. So event storming is going to be something like this, where people are basically putting their ideas on the board. And instead of putting simple ideas, what we're gonna do is we're gonna try to put events that are happening within our system. Okay, so let's say an e-commerce website. What can be the events? A cart created, cart emptied, product removed, cart abandoned, and so on. So you probably already can imagine what the events can be. Then we're also gonna go to commands like close to checkout, can be a remove product, and so on. And also we're gonna identify the users, which are, for example, a retailer, or a customer, and so on. And we're gonna have policies. Now, I'm not gonna dive deep into event storming in this video. I'm gonna do it in the next video. But I want you just know that in the event storming, developers and business experts are basically gonna gather in one room. Maybe it's gonna be not just one meeting, but several meetings. And they are going to be posting post-its on the wall with all the events to basically better understand what the business is all about so that everyone has a common knowledge. Okay, next thing is going to be improving the communication. And the communication is based upon the ubiquitous language. What DDD basically is saying that developers as well as business people need to agree on the words that they're using. So for example, in a drone delivery app that we have here, we have different ways of delivering. Delivery by drone, delivery by FedEx, and express delivery. We're gonna agree that these are the methods and not ways, okay? There can be a case where business people are gonna call this delivery ways and developers are gonna call it delivery methods, and then they're gonna use it in the code, and then it's gonna be a difference between the word usage. So we want to avoid that because the book of DDD implicitly says that it's very important to agree on the common language. And this is gonna be playing a big role in the future. All right. And what we're going to do next is basically analyze the domain, our domain. So we're going to take this event storming, post-its from the event storming, and we're going to try to cluster them somehow. Okay. We're going to put similar post-its next to each other. For example, let's take a look here. So product added is going to be in one corner, cart emptied is going to be in a different corner, or I would even say everything cart related is going to be in one corner, and then product related going to be in a different corner. And by clustering that, we're going to be able to identify our core subdomains. Okay, so within a drone delivery app, now let's go back to the drone delivery app, forget the e-commerce. Our core subdomains are basically a drone or maybe shipping subdomain. Okay, shipping subdomain, I would say even payment subdomain, but the core is obviously shipping because we are a shipping company. Okay. Now we can also agree on supporting subdomains. Supporting subdomains are the ones that are not core, basically. For example, payment subdomain. But what the DDD book is saying that core subdomain should be the place where your business gives the most of the value. So the code here in the core subdomain has to be written by our developers, by us. In the supporting subdomain, we can use external APIs and so on. Okay, we can use external APIs, but these are also going to be very necessary supporting subdomains that are basically not core, but they're supporting the core subdomain. And the generic subdomains are basically the subdomains that can be totally outsourced, or there can be a third-party program or software such as SAP or Salesforce for sales that can completely be outsourced and not developed by our our developers. And this is why it's important to identify or perform the domain analysis here. And now that we did the strategic design, we know where our core subdomains are, supporting subdomains are. We agreed on the ubiquitous language here, and we successfully performed the event storming, and we know what the value we're going to provide. We can finally jump into some technicalities. Okay, this is where the actual fun begins for us developers. Now, technical design lives within the solution space. Okay, it's not a problem space anymore. It's not theoretical. It's more solution oriented, it's more technical. So the technical design is going to consist of the bounded context. Okay, bounded contexts are very similar to subdomains like these here, but they can span across multiple subdomains. More on that later. Okay, so we're going to identify our bounded context from what we have here, and we're going to have entities within these bounded contexts. And entities can also span across multiple bounded contexts. We're going to look at all of these separately, but just keep in mind that we have entities, we have value object, we have aggregates, we have domain events, and we have domain and application services. Now, you didn't understand anything from any of that. This is totally fine. That's why let's jump into the entities. So we have one thing called entities, and within the technical design, you need to identify these entities. So what are the entities basically? Entities are unique things that you have within your application. For example, a drone is going to be an entity. Okay, drone is going to be an entity because all the drones are unique. An account is also going to be an entity because every account of a person is unique. Entities can also span multiple bounded contexts, and attributes may change over time. Yeah, account, the address of a person can change. In the drone, the color of the drone can change. Okay, so entities are basically the main classes of our application, because we're gonna take a look at the code as well, and you're gonna see that our source folder is divided into 3 parts. Now we're gonna have domain and entities, and we're gonna have different entities: account, confirmation, delivery, drone, notification, and so on. This is Node.js with TypeScript, so don't be surprised. This is what I use on this channel, but let's take a look at the drone class. So it's basically a constructor that accepts multiple things: ID, so that's why it's unique, status, battery level, and so on. Okay, this is an entity. Now, what's a value object? Value object, on the other hand, doesn't have any ID. It's defined by its values instead. Okay, so in other words, value objects are basically this stuff, or it can be this stuff. For example, battery level, it's a property of a drone. Okay, and in the delivery, it can be status instead. In an account, it can be email or password. Now we're going to talk about why value objects are so important. Also, they're immutable. Okay, if you need to change the value object, you need to create a new one. You cannot just overwrite them. This is the main difference of entities, apart from them having no ID. And also, value objects are basically the basic building block of the domain model. They are the lowest level of the building block. Okay, so first you have the value objects, and then you build an entity on top of that. Okay, you cannot have just a password to be a separate class. You need to password to be a property of a class. Okay, basically value objects are properties. Now let's go into aggregates. Aggregates, basically they cluster one or more entities into a consistency boundary. Also, they always have one root entity, and all other children are referenced by the root, and usually they are bound to a transaction scope. Okay, this is very important to know. Now let's take a look at the aggregate. Let's take a look at the delivery aggregate. So in the delivery aggregate, we are using the delivery entity. Okay, in the drone aggregate, we're using the drone entity. Now this code is not full because this application has not been developed, but basically what you can expect here is, for example, let's copy this and go to the drone. So the drone aggregate can also include the delivery entity. Okay, and then here you're basically going to perform all the logic that you're performing when these two entities are dealing with each other. For example, the delivery may ask the drone battery level. Okay, then you're gonna have a method here that's basically asking for the drone battery level and returning it. Okay, so as simple as that. Now let's remove this and go back. Oh, we also said one child is root. Okay, so in this one, the drone aggregate, the drone entity is basically gonna be the root entity, and also it can cluster one or more entities into a consistent boundary. And the most important part, in my opinion, is this one, usually bound to transaction scope. What does it mean? So the reason why we have aggregates is basically to add another level on top of our architecture of entities and value object. Basically, aggregates are gonna look like this. So if we go here, so we have a shipping bounded context. So we have delivery entity, we have package entity, we have confirmation entity, and notification entity. Aggregate is going to encapsulate these into one. Okay, so this is gonna be one aggregate, even though we have one root entity and two child entities. Now, why is it all together? Well, the reason is whenever there's a transaction happening, they have to be committed all together. If you're not sure about what transaction is, so within the database world, whenever you want to change multiple fields of the database, for example, this one and this one and this one, you don't have to make separate updates to the database field. Instead, because this is kind of risky, because what if this one fails and this one doesn't fail, and then only one record is going to be updated. Instead, you can do a transaction like this that is basically going to update all three at the same time. And if one of the updates fails, it can easily be rolled back. So this is why we have aggregates as well. For example, if we want to update the delivery here and we want to update the confirmation to say that it's confirmed, the delivery has happened, maybe this one fails and then we can easily roll it back. Okay, this is basically why we need aggregate. Okay, and it's going to be the same here. Package also has tag. Now, what about these graphs that we have here? This is just to illustrate that we're using not the hexagonal architecture, but the clean architecture within domain-driven design. So you probably noticed that all of this is very object-oriented. So we're working with classes, dependency injection, and so on. So basically we're going to have our domain model, then domain services are going to be using that, then application services are going to be using that, and more on that in a minute, and then we're going to have tests, user interface, and infrastructure. What does it mean? So we have our domain folder where all our classes are living, like entities, events, and aggregates, and so on. But what happens when a request is coming to our web server? They have to be handled within a controller, right? The controller is going to be living within controllers here. And now I don't have any controllers, but imagine it's just a normal Express application with a controller. And then these controllers can import one of the entities or aggregates and then use them under the hood. Okay, this is going to be pretty cool. Now, another point about all this architecture that you're seeing here is that you don't have to follow this pattern. So you don't have to really have a entities folder, services folder, value objects folder. I can understand that this is kind of ambiguous. What is value objects even? It's very theoretical. So instead, you can create just within your domain folder, you can create folders that are named after your entities, or they're named after your aggregates. And then within each folder, you can have your classes like this. Okay, so it's up to you how you want to design your folder structure. Just make sure that it's object oriented. Okay, it's divided by domains very well. All right. So another example here is that when a request comes here, you're going to see that application service is taking care of it first, like a controller and the controller services. Then we're going to have domain service, and then we're going to have aggregates where the logic is happening. And then aggregate basically depends on the entity and value object. Okay. And then we can also produce domain event. More on that later. And also this funny image that I found on YouTube. Why do we need aggregates? Because otherwise it's going to be a mess. So aggregates are basically good for combining and structuring your entity. All right, now let's take a look at services. Basically, services are going to have no state. Domain services encapsulate domain logic. So for every domain, you're going to have service that can do some logic manipulation. And we're going to have application services such as auth and emailing. Going back to the code, our application folder here has services as well. This is going to be dealing with application-wide things such as emailing or authentication. But also our domain has services, and these services are going to be bound to our entities. Okay, so for example, create account and so on. And one question about repositories. What are actually repositories? Repositories are basically files that are dealing directly with the database. So to save or find something by ID from the database, just another level of abstraction so that you don't have to put your database queries into services. Okay, if you're doing Java or if you're developing with Java and Spring Boot, you probably already know that. And it's the same in .NET. All right, the last thing would be domain event. What are domain events? Basically asynchronous, for example, RabbitMQ events. So they're going to facilitate async messaging between bounded contexts, and more on that in a second. All right, so what else do we have? Another entity here within the shipping boundary, bounded context, I mean. Another entity, location, ETA, package weight, drone status, delivery created. These are actually events. So every time a delivery has been created or delivery has been completed, we're going to emit an event. And then other bounded contexts can actually subscribe to that and work on it. And more on that here. So for example, if we have bounded context A and bounded context B, it's basically impossible for them not to work. For example, bounded context A is about shipping, okay? And bounded context B is about payments. Now, before the shipping begins, we need to make sure that the payment has been completed. So that's why the payment bounded context is gonna basically create a domain event. And then we're going to pick it up from here and process it. So, but there are three ways of doing that. First of all, partnership, integration events, or direct invocation. So in our case, I would prefer integration events, meaning basically these RabbitMQ messages or events that we produce. The second way is having a shared kernel. So bounded contexts can have like a shared folder where they're going to be able to talk to each other, through which they're going to be able to talk to each other. And also we have a third way, which is anti-corruption layer. I have a video on anti-corruption layer, but it's basically a layer in front of your system that's going to expose the endpoints so that your other bounded contexts can talk to this. And basically this is it lets you avoid to modify your bounded context, like a factory that exposes new ways for your legacy system to communicate to. But in this case, it's not a legacy system, it's just another bounded context. Okay, now the last thing that I want to discuss with you as well is also very, very important, and I left it to the end deliberately. So we can have a Anemic model, domain-driven design, in a domain-driven design, and we can have a rich model in a domain-driven design. So Anemic model is what we have just now. So I'm gonna go to entities, and I'm gonna go to, for example, drone. All right, so we have a very anemic model. What does it mean? It means that we're not taking advantage of our interfaces and our validations. So we can have an ID, which is a string, we can have a model, which is a string, status is a string, and as you can see, everything is basically made of primitives. Now, this is not good. What if we say that, I mean, it's again, just a hypothetical idea. What if we say that the ID, if ID is 0, like this, let's say if this is our very, very first user that uses our application, we're gonna make the battery level 100. To give this user a lot of range for flying. Okay, now we can either do this in a service, but then this is going to be redundant. Like the DDD basically says that make use of your entities as much as possible. And that's why we need to make it rich. What rich means is that you need to make sure that most of the times these properties that you have here are not primitives, but rather interfaces. So we can have a battery level interface and so on, just the way normal interface that you have in TypeScript, for example. And then you can either put the logic in there for validation, or we can say within the class or within the constructor even, we can say if ID is 0, then we're gonna make the battery level 100. So something like this. And this, why is it red? Let's check. And oh, okay, because string and this doesn't have any overlap, but of course, let's make it a number. Okay, like this. And this is basically going to put some logic into our drone TS. Otherwise, we have to handle this somewhere else. And this is going to be our rich model because entities are already responsible for most of their logic themselves. Okay, now guys, if you have any questions, write them down in the comments. I will do my best to answer them. And if you liked the video, of course, smash like, and I will see you in the next one. Goodbye.